So, hello everyone again. This is lecture 4 part 3 of wave optics. I am Sameer Lavankar. Let us move on with our discussion on incoherent and coherent addition of waves. So, just a little bit outline for you. We started with the introduction chapter. Introduction was about the wave theory, how is the wave propagation of light being happening, how it is different from the Descartes corpuscular model of theory, in which he explained everything by using very tiny particles. Then we also explained the concept of how the Huygens principle is being acted upon, what is the wavefront, what is the definition of wavefront, how can we calculate the wavefront value if we know that wavefront at some t is equal to tau, given that the wavefront is being known at t is equal to tau, t is equal to 0, and we need to calculate the wavefront at some t is equal to tau. Then that concept was being explained, how the ripples are being formed at some different time sources, explaining from a different primary disturbance. We also explained the geometrical construction of complete construction of a wavefront at some t is equal to tau. Then after this complete concept was completed, we understood the refraction and the reflection of plane waves using Huygens principle, in which we calculated the refraction. Let us say this is the interface, this is the medium 1, this is the medium 2. Then this was the incident wavefront, and how was a change in the wavefront being happening upon is being explained for the refraction, incident wavefront and refracted wavefront. Similarly, the same concept was being applied in the reflection wavefront also. And finally, now we are in the fourth concept, that is of coherent and incoherent addition of waves. So, here in the last lecture I explained to you what is constructive interference or destructive interference, also explained to you how the intensity is being changing. So, for constructive interference the intensity is I is equal to 4 I naught, and for destructive interference intensity is 0. Why it is 0? Because the value of displacement for let us suppose that the displacement from emanating at a particular point due to the source at S1 was y1 is equal to a cos omega t, then in constructive interference y2 is equal to a cos omega t only, which leads to the resulting displacement as 2a cos omega t. But the same thing in destructive interference was, if y1 is equal to a cos omega t, y2 was equal to minus a cos omega t, because due to this the resultant displacement was 0. Hence, the intensity in the first part was nothing but 4 I naught, and the intensity in the second part was, as the name was, destructive. So, it destroys, because it destroys, so it cancels each other, and hence the intensity would be 0. So, now today let me explain the complete concept, just a revising factor. So, what was coherent waves, then we explained to you for the point P. Then, so this was a point of 2a cos omega t, and finally we calculate the value of I is equal to 4 I naught. Similarly, we explained the same concept using the values of wavelength, that is n lambda for constructive interference and n plus 1 by 2 lambda for destructive interference. Similarly, now destructive interference was being done, and then finally we concluded the concept of if S1 lambda and S1p minus S2p was n lambda, then it was constructive interference, and if S1p minus S2p was n plus 1 by 2 lambda, then it was destructive interference. Today let us go on with this point again. So, now just let me explain to you again. So, let us use this diagram only on your right. So, what does this say is, let us suppose this is the source S1, this is the source S2. Let us suppose this is the distance small d, being talked about in some of the previous lectures. So, this line was nothing but the perpendicular bisector, and the concept of the first concept of which we calculate the intensity as 4 I naught was at any point which is situated on this perpendicular bisector denoted by point P. Because it was situated at the perpendicular bisector, therefore, by using the properties of congruency of triangles, we calculated that S1p is equal to S2p, and because S1p was equal to S2p, therefore, there was no phase difference, that is phase difference related to displacements did not change with time, and because it was not changing with time, the displacement was same. After the concept of point P, we included a point Q, for which the value of S1p minus S2p or S2p minus S1p was n lambda, and similarly for a point R, the R is not denoted here, for S1r minus S2r was nothing but n plus 1 by 2 into lambda. Now, we are calculating for a point G. So, now for any other arbitrary point G, let the phase difference between the two displacements be phi. So, here thus if the displacement produced by S1 is given by y1 is equal to a cos omega t, then the displacement produced by S2 would be y2 is equal to a cos omega t plus phi. Now, what is the use of this? We need to calculate the intensity for these point G. So now the resultant displacement will be given by, as we have already explained, as I already explained to you when I was explaining the concept of coherent and incoherent addition of waves. So y1 sorry the interference is nothing but the superposition of the displacement, that is the vector sum of the displacement. Either if the two sources are there, then it is the vector sum of two sources. If there are three sources, then there is the vector sum of three sources. So here the displacement is nothing but the vector sum of y1 plus y2, which is equal to a into cos omega t plus cos omega t plus phi. So here the simple mathematical formulation, that is cos a plus cos b is equal to 2 cos a plus b by 2 cos a minus b by 2 is being used. So now if I try to explain the same concept being talked about here, then cos omega t plus cos omega t plus phi is equal to 2 cos omega t plus phi by 2 into cos of omega t minus phi by 2. So this leads to 2 cos omega t leads to omega t only, which is omega t plus phi by 2 multiplied by cos of omega t gets cancelled, and we also know that cos of anything which is minus omega t is equal to cos of omega t, hence cos of minus phi by 2 is nothing but cos of phi by 2. So this is nothing but written here. So it is nothing but 2, also make sure that so this is just an addition of this, and because it is multiplied by a, hence it is nothing but 2a cos phi by 2 cos omega t plus phi by 2. So this is being explained here how it came. It came to using this mathematical formula, that is cos of a plus cos of b is equal to 2 cos a plus b by 2 into cos of a minus b by 2. So moving on now, so the amplitude of the resultant displacement is 2a cos phi by 2. So this is because this term of cos is not a function of t, hence it is also a part of the amplitude here. So now the amplitude of the resultant displacement is 2a cos phi by 2, and therefore the intensity at that point will be 4 I naught cos square phi by 2. How did this come? Let me explain you using mathematical formulation again. So now for the initial displacement y1, the value of y1 was nothing but a cos omega t. If we need to calculate the value of intensity, so we knew that the intensity at any point is nothing but directly square of a square, right. So I was a square here. Now if we need to calculate the value of y, y was using this mathematical formulation was found to be 2a cos phi by 2 cos omega t plus phi by 2. As we know that intensity is nothing but the is proportional to square of the amplitude, and here the square is 2 is here the amplitude is 2a cos phi by 2, hence intensity, let me write this is I naught, hence intensity is nothing but the square of 2a cos phi by 2, which is intensity directly proportional to 4a square cos square phi by 2. Now using this and this, if we divide those both equation, it will be I by I naught is nothing but equal to 4 a square cos square phi by 2 upon a square. Sorry, no, this is right, okay. So now a square gets cancelled, hence I is equal to 4 I naught cos square phi by 2, and this is the same mathematical formulation being explained here. So I is equal to 4 I naught cos square phi by 2. If phi is equal to 0, plus minus 2 pi plus minus 4 pi, we will have a constructive interference leading to maximum intensity, quite evident. So when we try to calculate anything here, so cos square of pi 2 pi etc will be nothing but plus minus 1 square, and hence it will be 1 only. So hence we will get I is equal to 400, which is the maximum intensity which can be obtained. On the other hand, if phi is equal to plus minus pi 3 pi plus minus 3 pi plus minus 5 pi etc, we will have destructive interference which will lead to 0 intensity. So this is being talked about here, this is 0 intensity, and this is nothing but, so from a particular arbitrary point G, if we know the phase difference for it, we can directly calculate if we can find out a constructive interference or we can find out a destructive interference. Now, if the two sources are coherent, so what does coherent mean here is, that is if the two needles are going up and down regularly, that is there is if the time lag between these two needles are being same apart for the complete time range, then those two sources are known as coherent. Now, if the two sources are coherent, that is if the two needles are going up and down regularly, then the phase difference phi at any point will not change with time, quite evident as it was explained in the first slide of coherent and incoherent addition of waves also. So, as the phase difference related to the displacements being observed does not change with time, hence those sources are known as coherent sources. So, it is just the explanation part, that if the two sources are coherent, then the phase difference will not change with time. Then the phase difference phi at any point will not change with time, and we will have a stable interference pattern, stable as in it will not change much. That is, the positions of maxima and minima will not change with time. So, the positions of maxima and minima will not change with time. What does positions of maxima and minima explain here? It is nothing but the displacement being observed or the intensity being observed. So, this is nothing but the explanation of coherent waves. So, this is also being done, this is also being done, this is also being done. However, if the two needles do not maintain a constant phase difference, so what is the definition of those needles which does not maintain a constant phase difference? This is nothing but known as incoherent sources. Then the interference pattern will also change with time, quite evident. For coherent it will not change with time, and for incoherent it will change with time. If the phase difference changes very rapidly with time, the positions of maxima and minima will also vary rapidly with time. So, please look over here carefully. So, coherent and incoherent are different values, but it is not directly opposite. Just to explain what I am saying is, if I explain or if I define coherent as something as the two sources whose positions of maxima and minima will not change with time, it does not mean that incoherent sources will have a pattern for which the positions of maxima and minima will change with time. The main definition of incoherent sources mean that it will also change, but please look over here this line very carefully, it will vary rapidly with time. So, this was the one of the point which I need to put very brief part upon, that is the interference pattern for incoherent waves has the positions of maxima and minima which will vary rapidly with time, and we will see a time averaged intensity distribution. What does time average intensity distribution means? It is nothing but, let us suppose we need to find out the value of time averaging for cos, then it will be nothing but integration of 0 to t cos of omega t dt upon integration 0 to t dt. This is nothing but known as time averaging. So, when this happens, we will observe an average intensity that will be given by I is equal to 4 I naught cos square phi by 2, where angular brackets represent time averaging, So, now if we need to find out the time average of this cos square phi by 2, then that will be nothing but the simple mathematical formulation. This will be equal to integration of 0 to t cos square phi by 2 dt upon integration 0 to t dt. So, now when you will try to calculate this, you will get the value of phi t which randomly varies with time, and time average quantity is nothing but 1 by 2. So, when you will try to calculate it, you will get these value as 1 by 2. So, this was one of the concept I need to explain to you. Now, this is also intuitively obvious because the function cos square omega t will randomly vary between 0 and 1 and the average value will be 1 by 2. What does this line try to explain to you is, let us suppose I explain to you using a graph here. As we are talking about time can't be negative. So, everything being explained is from this point only. Let us suppose we are trying to find out the time average. Let me start the time average from this point, let me end the time average from this point. So, it is quite evident that the value of this is always in the range of 0 to 1, as square is being talked about here. So, this is for cos omega t, this is for cos omega t. If I need to calculate for cos square omega t, then the diagram would be somewhat like this. So, now as the value is always between 0 and 1, if you try to find out the averaging part, then as you can see it is always between 0 and 1. So, when we try to average it completely over the complete time, we will find out the value between 1 and 2 only, between 0 and 1 only, and hence the value will be 1 by 2. This is nothing but a presumption, or this is nothing but to how to intuitively guess what will be the average value. But for mathematical formulation, you need to find out the value of time averaging like this only. So, moving on. So, the resultant intensity will be given by I is equal to 2 I naught. So, how will we get this value? Because cos square is equal to 1 by 2, hence I is equal to 2 I naught. Therefore, the resultant intensity will be given by I is equal to 2 I naught at all points. So, what are these points being talked about here is, these are those points which are neither having coherent sources nor having incoherent sources. So, now please make sure, so where does this intensity of 2 I naught happen? So, in the last explanation, when we talked about in the last lecture, I explained the concept of constructive interference and destructive interference. So, what is happening in constructive interference? The intensity is always 4 I naught. In destructive interference, the intensity is always 0. Now, we using this G point concept, using this phase point concept, we obtained a different type of intensity which is equal to 2 I naught only. So, when does this thing happens? So, now please explain, please look over here very carefully now. So, now when the phase difference between the two vibrating sources changes rapidly with time, we say that the two sources are incoherent. So, when does we say these two sources are coherent? We say these two sources are coherent when the phase difference phi at any point will not change with time, and we will have a stable interference pattern, that is the positions of maxima and minima will not change with time. What will happen in incoherent sources? Incoherent sources refers to those sources where the vibrating sources changes rapidly with time. So, this is nothing but a difference between the coherent source and the incoherent sources. Please do not mix up coherent and incoherent sources and constructive and destructive interference. For constructive interference, the intensity was 4 I naught. For destructive interference, the intensity was 0. For coherent sources, summation of addition, the intensity is 4 I naught, but for incoherent sources addition, the amount of intensity is nothing but the direct sum, that is 2 I naught. So, this is the difference. Please do not mix up destructive and incoherent sources addition mix up. So, when the phase difference between two vibrating sources changes rapidly with time, we say that the two sources are incoherent, and when this happens, the intensity just adds up. What does the meaning of intensity just adds up mean? It is I plus I, which is equal to 2 I naught. So, this is the explanation of this line. This is indeed what happens when two separate light sources illuminate a wall. So, this explanation is being talked about in subsequent slides for now. So, when does this happen? This happens only when, this is indeed when what happens when two light sources illuminate a wall. So, this is the complete concept of what is coherent and incoherent sources. Let me conclude the chapter here only, because then next concept, that is of Young's experiment, will be explained. So, just to revise everything what I explained to you, in coherent and incoherent addition of waves. So, first of all, we started with the concept of S1p and S2p. So, there was a point P, let me explain here only. So, in this what happened was S1p was equal to S2p, and hence the intensity was 4 I naught. When the point Q was talked about, then S1p minus S2p was nothing but n lambda, and hence again a constructive interference was being found, and the intensity was 4 I naught. Then there was a point R, for which the S1p minus S2p was S1q minus S2q, and S1r minus S2r is n plus 1 by 2 into lambda, for which the intensity was 0, and then finally there was a point G, for which there was a phase difference of delta, and hence we found out the intensity as 2 I naught. So, this is the complete concept of coherent and incoherent addition of waves. Now, a little bit of this will be applied in the next concept of interference of light and Thomas Young's experiment, that I will take up in the next lecture. For now, let me conclude it everything here only. So, now this is the course progress after the end of lecture number 4. So, now we started with the introduction is being completed, then I explained to you the definition of wavefront and how can a wavefront being formed by geometrical construction if we know the wavefront at some time t is equal to 0 and we need to calculate some t is equal to tau. Then in the third point we explained the concept of refraction and the reflection law. So, we explained for a denser medium, for a rarer medium, also Snell's law of refraction was being explained apart, then the reflection of plane waves was being explained, how is the angle of incidence is equal to angle of reflection, and finally I have already explained to you what is coherent and incoherent addition of waves. In the next lecture, I will explain to you the interference of light waves and Young's experiment, what does a beautiful experiment done by Thomas Young, how it was explained about different types of fringes being explained, light fringes, dark fringes, etc. Finally, the application would be a diffraction and polarization, and that will be the end of wave optics. So, for now let me end it here only. Thank you.